morning. Good morning, professors and colleagues. It's our pleasure to be here, kicking off the presentations for the thesis of this fall. I'd like to introduce my group, Tamima, Aya, Hossein, Muhammad, and myself, Zaina. And our thesis will be concentrating on materials with a special focus on pavement. And the title for our thesis is Rubber Modified Asphalt and the Validation of the Super Pave Model. Our advisors are Dr. Safwan Khidr and our assistant advisor is Dr. Maram Saud. The outline for our presentation will run as follows. We will overview some necessary background quickly, and then go through objective goals, scope, approach, and we will discuss the outcomes that we wish to reach, and finally the obstacles that some we've met and some still to meet. As we've all experienced on a daily basis, the Egyptian streets are just a web of problems. According to a study done actually in our university by some of our very own professors, all Egyptian asphalt sources fail to meet minimum performance grading system requirements. But what is performance grading? Also known as PG, we will abbreviate it and refer to it later in our presentation. Performance grading is a system that accurately characterizes asphalt binders and the performance in asphalt concrete pavement. The basic idea of performance grading is that it relates the asphalt binder properties directly to the conditions where it's used.
But why use performance grading compared to the traditional testing and design methods? Because for one thing, performance grading simulates real conditions of the asphalt. It accounts for temperature, it accounts for loading, and it accounts for aging. And performance grading also has a high reliability. When you design or test based on performance grading system, you know how your asphalt will perform. You're sure of it. However, traditional methods were more of an empirical method. They never gave you a higher reliability like performance grading. Performance grading is classified in the following system format. It's PG, X, and negative Y. The X stands for the average 7-day maximum pavement temperature, and the Y stands for the minimum pavement temperature. I stressed on pavement for a specific reason, because this is pavement temperature, but we need air temperature. We have air temperature. There's a model that converts air to pavement temperature, which is the LTPP model. It's a factor of air, latitude, and reliability of the air temperature. Like I've stated before, PG, X, and negative Y. X is the high temperature, Y is the low temperature. They account, performance grading accounts for the failure modes of the asphalt, such as rutting, which is because of excessive heat and loading, which is accounted in the X. Any further heating above the temperature X will be rutting. Fatigue damage, which is accounting in the aging process we perform in the asphalt, whether it's short or long term, but especially for fatigue it's a long term damage. And thermal cracking, which happens when the asphalt is in cold condition, it behaves like a brittle material, which is accounted in the Y. Any temperature below Y will result in thermal cracking. These are conditions we meet every day in Egypt, as stated before. So we need to find a solution.
Now, regarding to the objectives and the goals of our project, we are having actually two main objectives. One is main and one is secondary. Our main objective is to raise Egypt's asphalt quality to meet at least the minimum requirements of the PG requirements test. And you can have many ways to do so. You can just import a new technology from a foreign country and without knowing the know-how and use it and to actually raise the asphalt quality. However, our approach, we needed it to be more sustainable, that we know the know-how of it, and we needed to use local material, and we needed to utilize our waste material. And for that, we chose a rubber as a modification material for our asphalt binder. And actually, this idea didn't come from nowhere. We took it from a thesis group. We are continuing on their work. We're building up on their thesis. They are AUC students, and they worked on it 2 years ago. 2 years ago. And actually, but it wasn't their main objective, so that it wasn't very complete. So we are just building on it, and it's now our main focus. And the other objective, which is our secondary objective, it will be validating the LTPP model, which is actually a modular equation to transform the air temperature into pavement temperature, and we are verifying whether it holds true under Egypt's condition or not. And regarding our scope, regarding our time duration, it will be obviously 1 semester, and which means 13 weeks from now. Regarding the location, it will be in Egypt. We are just speaking about Egypt asphalt. And regarding our sources, we are having 3 asphalt sources and 2 rubber sources. The 3 asphalt sources are 3 factories. 2 of them are present in Suez, and 1 of them is in Alexandria. And we will try to get samples from the 3 of them, but we might manage to get only samples from 1 of them according to our limitations. And for the rubber sources, we are having 2 factories. One is called Hopek, which is in Sadat city, and the other factory is called Marsu, which is in the 10th of Ramadan city. And we will try also to get samples from both of them. Regarding our standards or codes that we will follow, we will follow the ASHTO codes and ASTM according to our experiment. And the type of rubber, we are using, like in the practical life, it's lean rubber, which is the inner tires rubber, which is actually soft rubber and close to in its properties to the asphalt binder. That's why we chose it. And the scientific name for this type of rubber, that which we will refer to it later, is the styrene butadiene rubber, or SBR. Now we will come to the approach.
For the approach, we have 2 major points: tests and materials. For the tests, we have 2 major tests: performance grade testing and LTPP tests. For PG testing, we have 5 tests. First one is the rolling thin film oven. It is used to produce short-term aged asphalt samples. For the pressure aging vessel, it is used to produce long-term aged vessel. For the RB test, it is used to study the bumpability of the asphalt during in the site or during construction. For the DSR test, it is used to test rotting, which is the ability of the material, of the asphalt material, to recover back from certain deformation. And for the BBR test, it is used to check the thermal cracks resulting from phasing conditions. For the LTPP testing, it is used to measure pavement temperature using heat sensors. Second thing, our approach is the materials. We have 2 main samples: controlled samples and modified samples. For the controlled samples, we will use unmodified asphalt binder. For the modified samples, it will mainly be the rubberized asphalt binder. For our schedule, we started our research 2 weeks ago and it will end by this week. After that, we will get our materials and visit the lab to be familiar with the different equipment and machines at the Super Pave lab. After that, we will be tackling the problem for 2/3 of our semester. At the end, we will be reporting our results.
What follows are a list of outcomes we hope to achieve by the end of the project. First, and most importantly, a solution to an everlasting asphalt problem in Egypt. Second, validating the LTPP model to the Egyptian conditions in terms of weather conditions and load conditions. Third, we hope that we get our results published in a respectable academic journal. And finally, we hope to acquire some very important skills by the end of working on this project, which includes academic research skills, teamwork skills, communication skills, and presentation skills. We are also expecting to face some challenges during working on this project. These challenges include acquiring resources. These resources are rubber and asphalt, basically. To help us obtain these samples, we contacted our advisors and some other resources that we know of, and we're still waiting for their replies. Also, due to the current conditions on the streets of Cairo, and due to the time restrictions and curfew, we have limited access to the lab. But the most important challenge is the new equipment and procedures we're dealing with. So we're taking our time to familiarize ourselves with these equipment and knowing if they're operational or not. Finally, we are trying to obtain university permissions to conduct some testings on its grounds. And to help us with this matter, we contacted Engineer Ashraf Sallour from Office of University Planning and Design, and we're waiting for his instructions to show us how to perform these tests. Finally, I would like to say that our main and hopeful recommendation is that by the end of this project, we can recommend that by using the inner tire rubber in the asphalt will increase the quality and reliability of the roads in Egypt and help by passing the minimum RP requirements. Thank you. Now we open the floor for questions.
Thank you for the first group. You did adhere to the time almost. You exceeded the time by about 2 minutes, which is okay, no problem. I think now I'm going to open the floor for question from the panel. Dr. Naguib.
Yes. First, I also liked your presentation, although I came a few minutes late. Just general comments and without going deep into technicalities. I liked the fact that you wanted, and I encourage all the groups, if applicable, that your goal should not only be limited to providing a report, but you publish your work if you think it's of new value. And I do think if it's done correctly. The second thing, in your last statement, I would just want you to caution a little bit, is that you should not appear at that stage that you're going to provide that recommendation. It may not work. You may find a reservation here or there. And I find that your first outcome was a little bit optimistic, or too optimistic, in that you're going to find a solution for the everlasting, or ending, lasting problem of asphalt. You contribute to that, okay? One thing, in case that helps, I think you mentioned the group last year who worked on the rubber in concrete may also have some contact, and that company Marso, which provides the rubber, I happen to know them, and I think they know them as well. So that may help facilitate getting the rubber for them.
Anyone else from the remember?
Yes.
Okay.
Is it economically feasible that we just use rubber? Would it be some sort of graded rubber or what?
I think it is economically feasible because the reason we chose rubber is it is a waste material. It's like recycling. And the company, the factories will
Because I didn't see that you ever mentioned this is a recycled material. You talked about rubber as if this is a new material.
We mentioned that we are utilizing waste material, and rubber is a waste material from the factory, from the truck industry in Egypt. The inner tube rubber, not the outer reinforced rubber. It's the inner tube rubber. It's lean rubber. It's not reinforced, and it's easier to mix with the asphalt.
The second point, you plan to measure temperature of pavement. Where that will be made, and temperature varies from 1 hour to another, and then so how do you plan, where are you going to do it? Where it will be safe that you take measurements?
We're waiting for Engineer Ashraf to tell us where exactly we can do this and like how we
Ashraf
can
has
do
nothing to do with your research plan.
Well,
Why don't you take the measurements at AUC? We have many structures.
Engineer Ashraf works here. He's the director of the Office of Planning in AUC. And he's going to show us where we can perform this where like there's no
في الاسفلت بتاع الجامعه اللي دكتور عماد زهر في الانترنال تريتمنت.
I don't mind, but I wish they just.
بس تشوحهم بس.
I don't think they need.
They are not going to go outside. So they're going to do it inside. So they are waiting for permission from Ashraf Sallour.
I wonder if really the equation that would relate the air temperature to the pavement temperature also accounts for where the wind is, whether there are shades or not. So that may somehow be taken into consideration where you could, and you would be. Did you consider what instrument you would be taking temperature measurements every 15 minutes, once a day, the worst at the highest temperature during a certain day.
Actually, we know that
I was hoping that this is part of your measurement plan.
we know about the sensors, the heat sensors, and we asked about them in the lab, and they are available. But we actually didn't go to the accurate procedures of when we use them and stuff like that. But Dr. Safwan told us that it's feasible. Dr. Maram told us that it's feasible and that we can do it with the heat sensors. So, and we followed the accurate procedure, but we didn't go deeply through it.
Let me just summarize that. We would like to see in the next presentation and in your report the exact scheme of when and how and where you would have the temperature measurement. So make sure in the next presentation that this should be included in the presentation.
اتفقنا مالناش دعوه دكتور سو قال لك ايه مالناش
Yeah.
دعوه.
But now we are speaking to you as engineers trying to sell the project to us. So regardless who is there, Dr. Qadr, Dr. Maram, Ashraf Saloom, we don't know them. We know only the 5 of you. Okay, so make sure that this will be included in your next presentation. Thank you.